It takes 19 organ implants to transform a regular human into a Warhammer 40k Space Marine. And in our last video on this topic, we managed to provide a modern medical solution for the first 6 gene seed organs and implant them into our gracious volunteer, Billy.
Like clay I shall mold them, and in the furnace of war forge them.
If you haven't seen that video yet, you may want to start there to check out what operations he has undergone thus far. Today we'll look at organs 7 and 9 as Billy, now aged 15, continues his quest to become one of humanity's greatest warriors. But why only 2 organs, you ask? Well, quite frankly, the multi-lung lives up to its name, performing a host of functions that in reality require separate mechanisms. The preamnur is no walk in the park either, so in order to keep today's class to a digestible length, we'll be focusing just on these 2. But never fear, we will continue our analysis of these organs in a few weeks. After all, we have no time to waste. There's no telling when the infestation will begin. Or who will attack first? The 40k universe is seriously a treacherous place. We'll have to exercise some creative liberty since we're attempting these operations 28,000 years ahead of schedule. Thank you, Long Coat Gamer, for correcting me in the last video's comment section. I'm really good at orthopedics, but not that great at math. And thank you to everyone who has offered input and supported this series so far. You guys are absolutely fantastic. It means a lot to me and the team to know that this type of content has a home here on YouTube. Now, with carte blanche in hand and access to all of the latest medical technology, let's see what we can do about the preamnur. This organ is introduced in phase 7 and it is essentially a pre-stomach that can neutralize otherwise poisonous or indigestible foods. No actual digestion takes place in the preamnur as it acts as a decontamination chamber placed before the natural stomach in the body system that biochemically analyzes ingested material and neutralizes most known biochemical and inorganic toxins. That's right, a Space Marine can comfortably enjoy everything from expired milk to toxic sludge. Yum. But before we go any further,
dude, what makes poison poisonous?
As certified toxicologist Anne Chappelle, featured here on Wired, goes on to say, poison is a general term used to describe a substance which can cause harm when ingested. But don't take it from me. Let's see what Anne has to add.
But it's really all about the dose. Low dose, less effects. High dose, generally higher effects.
Almost anything can qualify as a poison when it is ingested in sufficient quantities. Even water, but you need to drink a whole heck of a lot of it. We measure the toxicity of a substance with the Ld50 test.
It means you give a dose to an animal and you find out what the dose is that kills 50% of those animals.
On that scale, compare water to botulinum toxin, a substance produced by anaerobic bacteria with a lethal dose of 1 nanogram per kilogram. A single gram of crystalline toxin, evenly dispersed and inhaled, can kill more than 1 million people. I say this to illustrate the fact that there are many poisons with many distinct mechanisms of action, and therefore no universal immunity against all of them. With some careful planning, the immune system can be conditioned to resist some toxic substances to some degree through repeated micro-exposures.
Intentionally poisoning yourself with some toxic chemical to try to engender some kind of immunity today is called Mithridatism.
Thanks, Kyle. Mithridates was an ancient king who feared being poisoned so much that he regularly ingested small doses to develop immunity. The body's ability to tolerate a given poison depends on its ability to metabolize or break down said poison into a less toxic form, a task largely performed by enzymes in the liver. Thus, the poisons to which one can build immunity tend to be larger organic molecules.
I think that I somehow poisoned myself.
As a result,
you can drink snake venom unless you have a cut in your mouth or in your bowels that will allow that venom to get into your bloodstream.
But please do not even think about doing that. Just because the enzymes and acid in your stomach have the capacity to deactivate it does not make it dinner material. Now, it is important to note that this metabolic process is not effective on all types of poisons.
If I were you, I'd take
And exposure to certain toxic substances, such as hydrofluoric acid and heavy metals, is either lethal or has little to no effect.
For example, although snake venom and alcohol are both poisons, they have very different structures and affect the body in very different ways.
Great addition. And to bioengineer an organ that is equipped to protect the Space Marines against the entire gamut of possible poisonous substances they may encounter in the field would be practically impossible. And to mithridate our Space Marines sufficiently against the possible candidates, we would need to start the process of immunization even younger, subjecting the Marine to a lifetime of unappetizing delicacies.
Oh well, Hakuna Matata.
And that might be harsh even by Space Marine standards. Perhaps a physical solution will enable us to detect and eject toxic material safely, removing the need to neutralize anything. What if we modify the existing gastric bypass procedure? Now, normally this is a two-step operation that divides your existing stomach into a small upper section, the pouch, and a larger bottom section in the first step, then connects a small part of your small intestine, the jejunum, to a small hole in the pouch. The pouch holds a much smaller amount of food, and the intestine allows that food to bypass the rest of the stomach, causing you to eat less and therefore lose weight. If we adapt this procedure to create a small pouch separate from the main body of the stomach, we have a real-world scaffold for the preemnure. We could then direct the jejunum to the outside of the body into a pouch or bag, as we do with an ileostomy or colostomy, which are two different procedures that employ a similar method. Maybe the YouTube channel Animated IBD Patient can help.
An ileostomy is created with the last portion of the small intestine, called the ileum, so its output is essentially liquid.
On the other hand,
a colostomy is created with a loop of large intestine, or colon, so its output is more often solid waste.
Our preemnure could output either solid or liquid waste depending on what the Marine has ingested, and the stoma, term used to describe the opening in the body, would likely lead to a tube in the power armor that transfers the toxin outside the Space Marine suit. We would then need to introduce a series of mechanical sphincter augmentations to help regulate which valve is open when poison is ingested, the jejunum excretion channel or the regular stomach pathway. This mechanism could be controlled by the Marine manually or by external control, and automatically by a sensor. Somewhat applicable technology exists that uses magnets to help patients suffering from gastrointestinal reflux, and would need to be expanded upon to create a stronger seal with a bipolar on-off control. I found out while watching one of Wes Hammer's deep dives into 40K lore.
But when specifically talking about the diet of a Space Marine, the most common thing you're going to see is a wide host of different nutritional gels and pastes.
So in most cases, the smaller size of this pre-stomach wouldn't be a problem in the far future. But hold on. Though we have succeeded in separating the stomach into two chambers, the digestive function of the upper portion is still intact, and the stomach is semi-permeable like the other organs in the digestive tract. So some absorption occurs here. The stomach is not the only place where absorption could occur, so replacing the pouch with a small, biocompatible, toxin-resistant pouch wouldn't solve the problem. Once a poisonous substance is ingested, it comes into contact with permeable tissue inside the first two organs of the digestive system, the mouth and esophagus, before entering the upper stomach pouch. So we need to treat this entire portion of the digestive tract, including the stomach pouch of the Marine, to protect them. We can't really replace the entire digestive tract from the mouth to the pouch with a permanent, non-permeable, toxic-resistant material, since the esophagus and upper stomach are lined with smooth muscle layers that aid us in the digestion process. When we swallow something,
nerves in the surrounding esophageal tissue sense the bolus's presence and trigger peristalsis, find muscular contraction.
Then the stomach muscles simply contract and release to let food enter and mix it with digestive juices. Luckily, researchers at MIT are a couple steps ahead of us.
What we developed here is essentially a film that forms right over the small intestine, and we recognized was that we could embed drugs.
These drugs create a temporary synthetic coating on the GI tract that could either deliver drugs or aid in digestion.
But what we also recognized is that we could use that film to hold different tools.
They show us that it is possible to line a targeted portion of the GI tract with a polymer that has a flexible function.
The researchers show the darker color signals the transformation into the polydopamine polymer.
Liquid Pepto-Bismol functions in a similar way by coating the walls of the gastrointestinal tract.
Pepto soothes this area. It binds with proteins in the mucosal lining, enhancing the viscosity of the protective layer.
Somewhere between this cutting-edge science and the medicine cabinet delight lies the foundation of our solution. Prior to entering battle, the Space Marine would drink a liquid polymer compound designed to temporarily coat the mouth and upper digestive tract with a non-porous, toxin-resistant material.
Now that's enough to calm me down and stop me from seeing horse everywhere.
The magnetic sphincter would be activated to close the stomach and open the jejunum excretion channel, allowing only the section to be coated with the compound. Okay, biochemists, can you have that delivered by early next week? Use one of the world's most chemical resistant plastics maybe, but make sure that the polymer isn't toxic. Okay? I don't want these Space Marines drinking a gallon of Flex Seal before every battle.
It's like the Hoover Dam in a can!
Or maybe I do. Either way, the pre-stomach would need to be fitted with a permanent sensor capable of completing an immediate toxicology screening to test for dangerous compounds, the result of which could coordinate the opening and closing of the correct valve. This sensor would need to be covered when the liquid polymer is ingested so the polymer doesn't interfere with its function, adapted to take rapid readings, and fit inside a very small package. Give those notes to the engineering department. And just like that, poison comes in and the sensor triggers the ejection procedure, allowing the sons of the God Emperor to continue to do what they do best. Glory to the Emperor of Mankind. Another successful day on the battle. But this still doesn't solve the issue of the poisonous gases, which have nothing to do with the GI tract. We're going to take a small detour and address organ 9, the multi-lung, before we conquer the beast that is the homophagia. Oh, and Billy, you might as well get comfortable on the operating table since implants 7, 8, and 9 can be introduced simultaneously. The multi-lung is an additional lung that activates when a Space Marine needs to breathe in low oxygen or poisoned atmospheres and even water. The natural lungs are closed off by a sphincter muscle associated with the multi-lung, and the implanted organ takes over breathing operations. It has highly efficient toxin dispersal systems. This organ solves a lot of problems. Low oxygen, multi-lung. Poison gas, multi-lung. Drowning, multi-lung. Bad credit, multi-lung. Though all of the functions of the multi-lung are breathing related, they all require a different mechanism of action. This is like 3 organs rolled into one. Our lungs evolved to harvest oxygen from Earth's atmosphere, which is very specific in the grand scheme of things, to enhance their natural function for performance in very low oxygen, while simultaneously introducing the ability to filter toxins and breathe underwater in an organ the size of a single lung is, well, science fiction. We'll need to isolate variables and push existing structures and technologies to their limits to even come close. The ability to breathe in suboptimal oxygen conditions, to a small degree, could be first refined through expansive hypoxic training, which means training in low oxygen environments, such as those with very high altitudes, or
using one of these. An altitude mask. That was an altitude mask. Or an elevation mask.
Exactly, Global Triathlon Network, so that your body will learn to create the same amount of energy with a significantly lower amount of oxygen. Yes, your body can learn to function more effectively in an oxygen debt, and also to produce more red blood cells, which carry oxygen, as an adaptive response. Studies show this to be an effective means of increasing hemodynamic function with low risk if managed correctly. Simple breathing exercises, such as Wim Hof's famous technique, have also been shown to make lung function more efficient.
And with the 3 of belly breathing, the chest, and even within the head.
To maximize this effect, the Marines would be trained extensively in breath work, and our program would manipulate the oxygen in the Marines' direct environment over the course of their entire life, alternating between hypoxic, normal, or hyperoxic conditions, which increases the amount of oxygen your body has access to, depending on the current goal or activity. Hyperoxic training during exercise to increase potential power output and endurance, or post-operatively during the initial healing period. And hypoxic conditions the rest of the time, because tough love, bro. Grow a set. It is important to maximize the innate capacity of the existing lungs because I don't think adding a third one will solve our problems. First of all, research shows that people who are taller and have more lean body mass have heavier, proportionally bigger organs. So as our Space Marines grow in size, there won't necessarily be more space inside their body, considering the lungs are one of the largest organs in your body with an approximate 6-liter capacity when filled with air.
Healthy individual that did not smoke. Okay? Let's look.
Oh, wow.
Lung size can be estimated from the height and sex of the patient and is termed the predicted total lung capacity. Taller people have bigger lungs, and a man's lungs are larger than a woman's of the same height. This is a man's world. Now, this thread on Reddit was started by a man with 3 lungs, but he states that the condition had negative effect on his breathing and one had to be removed. Accessory lung, or extralobar pulmonary sequestration, is a rare congenital condition where a small piece of lung tissue is found adjacent to the lower lobe of a normal lung. This accessory lung is not connected to the airway and is non-functional. Normally, the lungs are divided into 5 lobes by the 3 main fissures. The left lung has 2 and the right lung has 3, which are similar to balloons filled with sponge-like tissue. Each lobe receives air from its own branch of the bronchial tree, but they all have the same function: bringing oxygen into the bloodstream and removing carbon dioxide. This process culminates in hundreds of millions of tiny air sacs called alveoli, where oxygen diffuses into hundreds of billions of capillaries containing red blood cells. In rare cases, accessory fissures occur that separate individual bronchopulmonary segments into accessory lobes. But again, these accessory lobes don't improve function. So what if we could replace one of them, or even a regular portion of lung tissue, with some enhanced version of an artificial lung? Well, though impressive, modern science's artificial lungs aren't yet small enough to fit inside the human body, let alone the biological footprint of a small accessory lung. William Feiderspiel of the University of Pittsburgh marvels that the lungs have a tremendous capability for gas exchange, and there's no man-made technology that can come close for efficiency. He and his team are making great progress, but their project has yet to enter human trials. We use an ECMO machine in modern hospitals, which stands for
extracorporeal membrane oxygenation.
Clunky when compared to the autonomic biological miracle that keeps us alive, but incredible in their own right. Contemporary ECMO machines bypass the heart and lungs, pumping blood outside of the body and then
pumping it through an artificial lung where it receives high concentrations of oxygen and carbon dioxide is removed before returning it back to the body.
At the University of Pittsburgh, bioengineering researcher William Feiderspiel and his team have developed a device that combines a pump and gas exchange that can fit inside a backpack, but it still requires an oxygen tank to function. From what I understand, the Marines' Power Armor backpack is equipped with an oxygen supply, so any artificial lung could draw the required oxygen from this. By the way, great artwork from Mikhail Civier on DeviantArt. While Feiderspiel and his team have made a huge step forward in modern medicine, it still won't fit inside the Space Marine's body. And even if it would, wouldn't implanting something less functional than the lungs be counterproductive? Rolf Rosaint, the director of the Department of Anesthesiology at University Hospital in Aachen, Germany, assures us that respiratory devices don't need to look like they do now, stating that we could miniaturize them. And of course, we are also exploring ways to achieve this goal. He suspects that 12 years from now, there will be an implantable solution suitable for long-term use. Sooner still, he says that we might consider smaller devices if we are only looking to take over portions of the gas exchange, such as an implant that assists the lungs in filtering out CO2 more effectively. Not this time. The real 21st century solution to poison gas is one of
These bad boys.
Which has a filter that removes particles, such as biological weapons, charcoal to remove certain chemicals, both or other parts. When the user inhales, air is pulled through the filter. I wonder if there's a way to put this technology inside my body. First, I considered adapting a lobe of the existing lungs as an air filtration system, but this would mean converting a section of tissue that is already at the tail end of a series of passages: pharynx, the back of the throat, larynx, the voice box, trachea, the windpipe, into the bronchial tubes, and so on. Extra tubing to return air back to the lungs and a sphincter to close it off when it is not in use would also be necessary. Cool, but rather impractical. An air filtration system functions best at the entrance to the airway. But if we need to find a way to place it inside of the body and it doesn't make sense in or adjacent to the lungs, maybe we can find a happy medium. In your neck and upper chest below the larynx, we find the trachea, a stiff, flexible tube that provides a reliable pathway for oxygen to enter and exit your body that already helps to filter air in two ways. Mucus produced in your trachea and bronchial tubes to keep passages moist and help catch dust, bacteria, and other substances. And the sweeping motion of cilia, small hairs in your respiratory tract, also helps to keep air passages clean. Measuring 10 centimeters long with a normal transverse internal diameter of between 15 and 25 millimeters in males and 10 to 21 millimeters in females, this could be a viable location for some form of air filter implant. Unfortunately, a standard military grade gas mask filter is a little large for this size opening, measuring 110 millimeters in diameter and 85 millimeters in height. Permanently replacing a section of the trachea with an air filter would give us some more space to work with. You wouldn't mind having an enormous second Adam's apple right below your natural one, would you? Who am I kidding? This is for the sake of humanity and you don't exactly get a say. Now, we'd need to find a way so that this filter is active only part of the time so that the Space Marines aren't constantly pulling air through it, causing unnecessary fatigue, lest they end up sounding like Uncle D. Breathing through a respirator is harder than breathing in open air. People with lung diseases, such as asthma or emphysema, elderly people, and some others have trouble breathing through them at all. Perhaps some adaptation of an inferior vena cava filter could be used inside the trachea. As the name suggests, this filter is commonly used in the inferior vena cava to prevent blood clots from entering the lungs. It resembles a metal spider, daddy long legs of course, or an umbrella without the fabric or handle. We could create a collapsible model that is lined with a thin filter and that attaches to the wall of the tracheal implant, closed like an umbrella until air filtration is necessary. If the filter skeleton were electromagnetic, it could be activated by an airborne poison detector located outside of the body, so that it deploys before the toxin reaches the lungs. Toxicologist Anne Chappell reminds us why this is important.
Certain poison gases, when you breathe them in, immediately destroy the lining of your lung. Then you really can't oxygenate your blood, and then
you can die. She goes on to say that poisonous gases can also work by
interacting with the cells within your body and stop them from being able to produce energy.
Which is bad, especially for the heart and brain. While it's possible that a sensor on the suit could activate the filtration mechanism in time, air travels relatively quickly, and for the safest outcome, the Marines should test the air before entering combat if possible, or even activate the filter preemptively if their enemy is known to use airborne contaminants. Now that I think about it, they may also snort the chemical coating we mentioned earlier to ensure no poison affects their cells through the nasal canal or sinuses. And that's the multi-lung, ladies and gentlemen. Now we can all breathe a sigh of relief.
Oh, okay. I see what you did there.
Oh yeah, it also allows underwater breathing. I almost forgot. This is a tough one. Breathing underwater is hard work for several reasons. A, water is denser than air. B, water contains much less O2 than air per unit volume. A better understanding of Gills will help us here. Thanks to Steve Griffith here on YouTube for the great clip.
Okay, so they are The gills, what do you notice about them? What do you notice about those gills?
Gills work on the same principle as lungs. Both have small specialized cells that transfer oxygen into the blood via fish epithelium and human alveoli respectively. But lungs do not have enough surface area to absorb enough oxygen from water. And the lining in our lungs is adapted to handle air rather than water. You may be surprised to learn that the distinction between gas and liquid matters less than the actual oxygen content of what is entering the lungs.
A mouse can survive unharmed for hours, completely submerged, breathing a special highly oxygenated liquid chemical compound.
Scientists have conducted some interesting experiments with humans and other animals breathing other liquids like fluorocarbons. Fluorocarbons can dissolve enough oxygen and our lungs can draw the oxygen out.
As long as the alveoli in our lungs can receive and exchange enough oxygen, they surprisingly don't care how it gets there.
While the ability to breathe oxygen-rich liquid would revolutionize deep-sea diving, effectively bypassing the pressure-related limitation placed on the lungs at extreme underwater depths, it doesn't help our Space Marines unless they find themselves sinking in a lake of fluorocarbons. So what about a nice set of gills where the multi-lung is supposed to go? Finally, we have arrived. I knew that this series would lead us to xenotransplantation. You know, the old cross-species switcheroo, putting animal organs into humans. Frankly, I'm surprised we made it this far without doing so. But despite some similar hardware, veins, arteries, and blood, Billy's body won't just accept a set of gills from a donor fish for several reasons. First off, fish are very distant from us on the evolutionary tree. Some researchers say the 400-million-year-old Australian lungfish native to the Burnett and Mary Rivers is the closest living fish relative to humans and other land dwellers. The Guardian has us covered.
Yeah, they're really ancient fish, so they literally have lungs as well as gills.
As we evolved to become humans, fish evolved to live underwater, and our genomes have had millions of years to drift apart. And even in less distant evolutionary relatives with more genetic similarities to humans, other mammals for instance, other challenges arise. But due to xenotransplantation's immense potential to solve the critical need for organs, tissues, and cells in clinical transplantation, and in our case, the need for our Space Marines to breathe underwater, we must soldier on. A 2010 article from the Expert Review of Clinical Immunology reports progress in pig to non-human primate experiments using potent pharmacological immunosuppressive regimens to prevent T-cell rejection and T-cell elicited antibody response.
Here in the lymph node, cells of the adaptive immune system called T-cells continually circulate between the blood and lymph nodes.
T-cells, also called T lymphocytes, are major components of the adaptive immune system. Their roles include directly killing infected host cells, activating other immune cells, producing cytokines, and regulating the immune response. And suppressing them is important when foreign tissues are introduced into the body. This clip from the Medical Research Council sums it up.
If the immune system is not controlled, the effector T-cells attack any unknown organism they find in the body.
But even when the immune response is suppressed and the initial xenotransplantation is successful, we're not out of the woods. The same study goes on to report coagulation dysfunction between the pig and the primate, as pigs do not have an antithrombotic or anticoagulant gene that is compatible with the primate genome. The result is life-threatening coagulopathy, broadly defined as any derangement of hemostasis resulting in either excessive bleeding or clotting in the donor recipient. One proposed workaround is using gene editing technology like CRISPR-Cas9 to edit the genes inside the animal to fit more closely with ours before transplantation is attempted. A technique like this takes time to refine, and researchers make slow, careful progress. Oh, and if you're wondering why we use pigs and not primate organs, an article by Dr. Marlon Levy from the University of Baylor Medical Center has the answer. First, the animal should be of compatible anatomy and physiology for the intended organ to function well in humans. Next, no possibility of cross-species, that is to say, animal to human, infection should exist. In fact, an ideal animal donor organ should resist human diseases, especially viral as well. Further, this animal species should be inexpensive to feed and breed, with short gestation times and multiple births per litter to achieve economies of scale, among other things. And thus, our best bet is the pig, which still separated from us 90 million years ago during evolution. Back to breathing underwater. Let's say none of the above challenges to xenotransplantation mattered, and Billy's body would readily accept the gills. Even our closest fish relative that I mentioned earlier, which mainly relies on gills to breathe, has a lung that allows it to breathe air when the oxygen in water is insufficient. Many larger marine animals use lungs instead of gills. Why would this be so? We can all thank Varun Sathian, a molecular and cellular biologist on Quora, for breaking it down. He explains, fish have to pump 40 times more water through gills than they would air through lungs to get the same amount of oxygen. Water is not nearly as oxygen rich as air. Gills have to be extremely efficient at extracting oxygen, and they certainly do a better job than our lungs. Steve Griffith weighs in again.
Well, it's about having lots and lots of surface, so lots and lots of capillaries are in contact with the water.
Right. So high surface area relative to their size and volume. And our Quora hero Varun goes on to say, these characteristics ensure that water passes over wall after wall of capillaries, with oxygen being extracted at every point. Thus, almost every little bit of oxygen dissolved in the fish's surroundings can be extracted. Unfortunately, as marine animals grow larger, the surface area to volume ratio of gills diminishes, so large animals are not able to intake enough oxygen through this process alone. For example, orca whales and dolphins have to instead take the energy expensive step of rising to the surface to get oxygen.
It just breached right in front of me.
And breach it did, my friend. This is relevant to our space marines who put out an enormous amount of energy, especially when deployed on a high-stress underwater mission or emergency. Something like this great clip from Smarter Every Day.
Holy cow.
Now just imagine that, but in power armor, surrounded by enemies like this. I really hope Marines are paid well. Now, the argument for Marines with gills is further complicated by the fact that humans are warm-blooded while other fish are cold-blooded, and we therefore require even more energy and oxygen as we work to regulate our internal temperature constantly. To compensate, we need to transplant a big set of gills. Maybe we can borrow some from a big great white shark?
You'll see a white shark's gill slits are very large. The reason, it needs a big surface area to obtain the oxygen required.
Just like our Marines would. And while these beautiful pieces of aquatic anatomy may make the most sense on a Marine's burly torso, they must be exposed to water to function. That is to say, they cannot be contained in their suit. More a la Harry Potter.
One.
Don't leave. I just want to be like you.
But way bigger. We can look forward to our burly protectors walking around with oversized gills attached to their necks. Like this. No, this. Dear God, what have I done? Thankfully, a Japanese designer has conceptualized a prototype for wearable gills called Amphibio. Although in 2019, when CNN reported on the project, it was still far from human trials. Apparently, it has been tested in a small-scale aquarium drawing oxygen from the water and was inspired by water diving insects which trap air bubbles on their skin. Very ambitious, and time will tell if Jun Kamei can pull this off. Even if he does, humans require so much oxygen that the design incorporates a vest and headpiece. And don't envision the Space Marines having the opportunity to don a new garment in the thick of battle. I feel like 20th century Space Marines might rely pretty heavily on their oxygen tanks like those in a spacesuit. Maybe the Secret Salamander chapter can save us. They're totally canon. No. Seriously. In a study published in Proceedings of the National Academy of Sciences, researchers found oxygen-producing algae had bonded with their eggs so closely that the two are now inseparable. This marks the first documented case of a plant living in partnership or symbiosis with the vertebrate. These little guys are literally part plant. In humans, symbiosis of this kind could mean swimming without coming up for air. Lead researcher Dr. Ryan Kearney said, "The algae inside the egg capsules provide oxygen to the embryo, and the algae gets waste from the embryo, which is rich in the nitrogen the plant needs." He goes on to explain, We also found algae DNA in the reproductive organs of the adult salamanders, so it seems possible that it is being inherited. In order to continue his research, Dr. Kearney received a $1 million grant in hopes that his technology could one day be applied to humans. Okay. Do you see why today's video only covered 2 organs? True to its name, the multi-lung proved to be a freaking handful. I'm intimidated to find out what comes next. Whew. And next, if you're looking to train to prevent injury and move better, please check out my free online gym, Human 2.0 Fitness, right here on YouTube. As always, that's been a word from Dr. Chris, not your everyday ortho, where we see one, do one, teach one.